Welcome to Learn PTE HUB. I'm Sidhu, and I'm here to help you ace your PTE exam. Whether you are just starting your PTE journey or looking to boost your score, you've come to the right place. On this channel, you'll find comprehensive lessons, expert tips, and practical strategies to master every section of the PTE exam. Don't forget to subscribe and hit the bell icon so you never miss an update. Let's get started and conquer the PTE together.
Have you ever wondered how people got ice before they had refrigerators? For thousands of years, people have been finding creative ways to collect and store ice, even when it's hot out. You can harvest it off mountains where it's frozen at high altitudes, or even in the desert where water freezes overnight. People would take this ice, pack it together as densely as possible to insulate it from the heat, then store it in ice houses, subterranean structures that kept it dark and cool. In ancient Persia, ice was stored in a yakchal, a large underground storage chamber with a tall conical roof that allowed warm air to rise and escape out the top. Back then, year-round ice was a luxury consumed by the wealthy. It was mostly used to make desserts and iced drinks. It wasn't until the 19th century that ice became an industry. In the 1800s, people began harvesting ice in huge blocks cut from lakes and ponds in New England, then shipping it all over the world by barge or railroad. By the 1860s, access to ice transformed the way meat and produce were stored and transported in the United States. Ice entered the American household shortly after ice became an industry. You've probably heard someone call a refrigerator an ice box. Before electric refrigeration was possible, that's what people had. Boxes in their home, often made of wood and lined with tin or zinc, with a block of ice to keep the items inside cold.
The battle for climate change will be won or lost in cities.
Cities play an outsized role in climate change, consuming around 75% of the world's energy and producing more than 70% of greenhouse gas emissions. But they can also be part of the solution, creating meaningful impact while being small and nimble enough to avoid the bureaucracy of global politics. In fact, many have already started work. 2022 marked some of the most extreme weather events on record, with wildfires and droughts ravaging parts of Europe, the US, and Africa, while Asia battled disastrous flooding and monsoon rains. And experts warn it's just the beginning.
What we calculated and what we knew as a 1 in 10 years event is now becoming 1 in 5 years. So the frequency is increasing.
Our cities are at the forefront of those shifts. Today, more than half of the world's population live in urban areas, a figure that's set to rise to 68% by 2050. This migration pattern is driven partly by the climate crisis, which, in turn, creates new risks and stress for urban infrastructures.
We have all seen the planetary model of our solar system since back in our school days. The planets are shown to revolve in a nice circular path, forming concentric rings, with the sun sitting smack dab in the center. While this vision of planets following a nice circular path around the sun looks neat and tidy for a school project, in reality things aren't that simple. The planets in our solar system don't really revolve in perfectly circular orbits. Instead, they generally have a stretched version of a circle, which is technically called an ellipse. How stretched, you ask? Well, that all depends on the orbital eccentricity that the planets possess. Too much mathematics going over your head already? Well, let's get the basics down first. An ellipse is a symmetrically shaped, closed oval. It has 2 points, called foci, which act as a combined center for an ellipse. This ellipse has an important property called eccentricity. Simply put, eccentricity tells how much the ellipse deviates from a perfect circle. Mathematically, the value of eccentricity varies between 0 and 1, with 0 representing a circle and 1 transforming into another shape, called a parabola. For planetary objects, when orbital eccentricity crosses 1, the planet no longer remains confined to the star, and it escapes from its gravitational influence.
There are 4 types of solar eclipses. The first and most spectacular is a total eclipse, when the moon completely covers the sun's surface. A total eclipse can only be seen if you're standing within the umbral shadow. That's why the imaginary line created by this shadow as it races across Earth is known as the path of totality. People within the penumbral shadow see only a partial eclipse, the second type. From this view, outside the path of totality, the moon passes in front of the sun off-center, never fully covering its surface. Third, an annular eclipse occurs when the moon passes directly in front of the sun. However, unlike a total eclipse, the moon appears too small to fully cover the sun. The moon's orbit is elliptical, so sometimes it's closer to Earth and sometimes it's farther away. Last, a hybrid eclipse is when the moon's position between the Earth and sun is so finely balanced that the curvature of the Earth plays a role. The moon will be farther away from some parts of Earth along the eclipse's path, resulting in an annular eclipse. In other parts, the moon will be just close enough to fully cover the sun, resulting in a total eclipse.
Telescopes and eyes are both tools for collecting and detecting light. In fact, telescopes can be thought of as bigger, more powerful eyes. The type of lenses and mirrors and their arrangement determine some of the features of the telescope. The resolution of the telescope is a measure of how sharply defined the details of the image can be. The telescope's primary mirror may have a fraction. As a result, starlight is not brought to a focus at the same point, resulting in blurry images. The name telescope covers a wide range of instruments. There are major differences in how astronomers must go about collecting light in different frequency bands. The telescope is widely used in the astronomy field because it is a digital detector, 100 times more efficient than our eyes. Now physicists have begun to develop a various quantum mechanism.
If you did, please give this video a thumbs up and subscribe to the channel for more PTE-related content. Don't forget to leave a comment below letting me know what you think, or if you have any questions. Thanks for watching. I will meet you soon at our next video.